been killing you with videos lately, but I want to do this actually in class with you guys so we can kind of have a conversation. But honestly, I'm not feeling very well right now, and I have to go home. So video is all I got for you. Now, at the end of the day, this is going to become really important. This is consolidating all the work you guys have been doing in those investigations, which I know have been tough, and also the notes I had you guys take. This is kind of like a cheat sheet, like a quick consolidation of the information. And yes, you can use this on the quiz that I'll be giving you later today, or at least the sub will be giving you later today. So let's just get into it. Let's get through this as efficiently as we can. And so one thing we have to get off right off the understand right off the bat is that you guys have been moving these shapes using these three things. But the whole time you've been doing something called a rigid transformation. Now transformation is just a change, we know that, but this term rigid might be a new one for us. When I talk about a rigid transformation, what I'm actually talking about is a congruency transformation. What I mean is you're making an exact copy. So whenever you hear the word rigid, it's an exact copy and there's no changes. In other words, you're going to have congruency. So the shape you start with and the shape you end with are going to be the same. And so let's just kind of consolidate the information that you have in notes. Again, this is the idea of this, just a quick cheat sheet. And so when you have translating, we can describe that maybe a couple different ways. One way we can describe it is that you're just sliding an object, or maybe you're just pushing an object around the grid. And again, we're not changing the object. What we're actually doing is just moving it to a new location. So verbally, if you want a nice description, a rigid transformation is a transformation that moves the shape or maps the shape using what we call vectors. Now remember, vectors are just going to be a directional movement. It has distance and direction, and we see like that as a vector. And maybe the wording here has to be changed a little bit. It uses vectors maybe to form a, let's change that around, to form parallel and congruent lines. Okay, and so again, this is not new information, but maybe visually makes a little more sense to what I'm talking about. Um, if you look at the pre-image to the image motion, in this case, the red object is what we call the pre-image. It's a pre-image because if you look at the vertices, it's just A, B, C. If you look at the blue one, the vertices are A prime, B prime, C prime. They have that little tick mark. So we're going to call this the image, which is really just a copy. Okay, where the pre-image is like the original. So when I say it moves along vectors, if I look at the pre-image A and connect it to the image A prime, this forms what we call a vector. It moves to the left and up, and that should be the same for all of them. In fact, what it could do is take this guy and copy it, and it should be the exact same for every single point from A to A prime. In fact, if you look at me moving this shape along the red, you notice it matches the blue perfectly, which means every single point from the red is going to move to the blue along this line. Now we don't have to write all those, really just represent it using three vectors, one for each point in this case. And then since they have to be parallel and congruent, we can mark them as such. Now of course they're parallel because they're obviously moving in the same direction. You saw me copy and paste it, which shows that the vectors are going to be the same size. So that's what that's how we're going to move the red to the blue. This thing is literally the vector. Okay? And so structurally, like that's what you have to show to know that a translation happened. If you can't show these vectors, you can't prove that you actually have a translation. Now this goes to we can consolidate this into a formal rule. Now the formal rule just tracks what happened. It doesn't help you create it. This just explains what happened. All right. And so the formal rule in this case would be T, which stands for translation. Now, right below the T as what we call a subscript, we have to write the vector. The vector, the notation is these two brackets, and in that vector you have to track actually how it moved. And now for this example up here, going from the red to the blue, we have to go up 3 units and then over 1, 2, 3, 4, 5 units. And so we go up 3, that's going to be that. If we go back 5 on the x's, it's going to be minus 5. Because this tracks a motion. This is a vector. Okay, and that tracks how it changed. Okay, and then we have to track what it was and where it goes. So it starts with triangle ABC. Okay, so that's going to be our pre-image. Okay, and then it goes to our new image, triangle ABC. And these are primes because that's going to be our image. Okay, and so you have to be able to track what happened with a formal rule. Now the coordinate rule is just telling you actually how to create the new object or create the image. And so with this, we expect to see some kind of x and y mapping because we're on a point. And so our coordinate rule starts with an x and y, and it tells us to get that x and y, we have to do the x with something, and then we have to do the y with something. Now, if you look at the vector, we can actually read it right off this guy right here. The vector being negative 5 comma 3. That literally says take our x, subtract 5 from it, and our y's, and add 3 to it. And so whenever you see like addition and subtraction, that's a dead giveaway that you actually have a vector motion. Okay, that's not going to be the case for the rules, but that's what's going on. So in the quick summary, if we're going to make an exact copy, no changes, a rigid transformation, we got to use vectors, and those vectors form parallel and congruent lines between the pre-image and the image, which is what you're seeing here. These purple lines are the vectors. The formal rule explains what happened. The form of the formal rule is using a little t for translation, marking down the vector right next to it because that's really important information, and then saying, well, we have to start at ABC and then at A prime, B prime, C prime. You can also use that, create a coordinate rule or use a coordinate rule to do it. And if you notice, like the back 5, the x minus 5 is here, just like it was in the first place in the vector, and the y plus 3 is also there, same place as the vector. Okay, let's talk about reflecting. So with reflecting, again, if you want to use a quick kind of term for it, reflecting just means a flip. Another way to look at it is a mirror. Okay, so if I want to describe this in words, it's again a rigid transformation because I'm not changing the object at all that moves a shape or maps a shape using, in this case, a line of symmetry, or you can also call a line of reflection. And again, let's change the verbiage here. A line of reflection to create. Okay, so use line of reflection to create a perpendicular bisector. Let me explain what I mean by looking at the structure. So if you're confused by perpendicular bisector, let me try to make some sense of it. So if I'm looking at these two objects, and I don't know which one is the pre-image or the image because it's not marked ahead of time, what I am saying is that it has to flip, and in this case has to flip over a line. And so in this particular case, the line I'm looking for is going to be the y-axis. This is going to be my line of reflection or my line of symmetry. You can call it either one. The reason I know it's my line of reflection or my line of symmetry is because if I take the one point and I trace it all the way over to the point to which it's been reflected, two things are true. One, they're the same exact length. From D to the red line is 1, 2, 3, 4 units, and from the red line over to G is 1, 2, 3, 4 units. And so these are going to be congruent. That's what I mean by bisector, because bisectors mean that it's equal length on each side. But also, if you look at the orange line and the red line, these are going to be perpendicular. That's what's meant by perpendicular. And so as long as this happens, you can guarantee that reflections happen. Check out C to H. So C has 2 units into the line, 2 units out to H. They're the same length, but also at the same time, they intersect in a perpendicular manner. B to E, same thing. B to the line is 2. Over there is 2. And so 1, 2, 3, 1, 2, 3. That's going to be my bisecting part. That's going to be my perpendicular part. A all the way to F. Again, same amount of units, 4 units again, and then looks like it's going to be another perpendicular. And so if this happens, if this is a structure you see, you can guarantee yourself a line of reflection. Now, if it's not perpendicular and it's not been bisected, no bueno. You can't actually use it. But in this particular case, we do have a line of reflection. Ergo is going to be a reflection. Now again, consolidating this into a formal rule, we're going to use little r for reflection. Okay, so that means reflection. We have to incorporate important information right here, and the important information is going to be my line of reflection. And so that's my line of reflection, that's the y-axis, and so I just have to mark that somehow. And so if I'm reflecting over the y-axis, notice I'm writing it small and just next to it. So you read that, a reflection over the y-axis, so that's the important information, the line of reflection. And again, we have to track where we are and where we're going. Now, in this case, I don't know. So I'm just going to pick DCBA as being my original. And I'm saying I'm taking it to the new image. And I have to mark this the same way. So if I started at D, I have to start at G. So GHEF. Okay? And again, we have a pre-image. I'm just going to mark PI. And then my image, I'm just going to mark as I. Okay? Now, the formal rule, or the coordinate rule, there is one for this. In this case, you're going to take x, y, and you're going to move it to the opposite value of x, but you're going to keep your y. And so for this one, it's not really important that you actually have the perfect coordinate rule. It's important to note that you're going to see some common things. And so the most common thing for the coordinate rule for reflections is that you're going to change the sign of x or y. Now, in some cases, you change both. In some cases, maybe some other stuff happens. But in general, this is what's really going on. And honestly, coordinate rules aren't that important. Formal rules are actually much more important, which is why I want to focus on those more than the coordinate rule. I just want you to know that they do exist. You can tell what they are by looking at the coordinates, but really that's what's going on. Let's go one more. Let's talk about rotations. Now, this is the one that's probably the weirdest one, but rotating basically just moves in a circular motion. Or moves in a circle. Another way to say that is that it spins. Okay? So this one can be described as a rigid transformation that moves a shape or maps a shape using a circle. And we'll change the verbiage here a little bit so that it moves the same amount in an angle. Okay? And again, let me try to explain what that means. I know that it's a weird sounding thing, but let's talk about this guy. And again, we don't know, we're not going to know which one's the pre-image or the image. So let's just say this right here is going to be the pre-image. And I'll explain why in a second. So this is not going to be perfect because I'm kind of freehanding this, but kind of just bear with me. If we take the center here, the origin, to be the center of a circle, and we use this point as another point of our circle, it's going to move to its other by traveling along this entire circle. Okay? The same thing is true about, let's say, the center in this guy. We're going to travel on a circle that goes from here all the way to there. Okay, I'm not going to draw the whole thing. I think it suffices to do that. And then again, for this last one, we're traveling on a circle. This is the hardest one to kind of visualize. The other ones I think are really straightforward. So you really have to pay attention to the object. Now, in terms of an angle, what I mean is this. If you connect the pre-image point into the image point and look at the angle that it forms, it looks like that one's going to be a right angle. If we do that for the other ones, if I connect this guy and I connect this guy, again, you can see we have a right angle. One more time, if I connect this guy point and this guy point, we have another right angle. And so if these are the two things that have to happen. Like one, you have to be moving along a circle. And two, you have to be able to look at the angle between the pre-image, the center, and the image. And as long as all those are the same and moves the same angle, then you got a rotation. And so even though it's a spin, it's a little bit more complicated to track, but it's not impossible to track. Now, another thing I want you to make note here is that the default is always counterclockwise. And so if you're going to make a rotation, you have to default that you're going to be rotating counterclockwise. And this one is, which is why I took the right-hand one to be the pre-image, and then I took the one that's still outlined in black to be the image, because I know things have to rotate counterclockwise, which is like this. Yeah. We can consolidate this into a formal rule, so let's do that. So the letter we use for rotations are a big R, so R stands for rotation. we have to track important information, and there's two things that are important here. The two things that are important is that you need a center, and in this case it's going to be 0, 0, and then you need an angle of rotation, which in this case is going to be 90 degrees because the angle was 90 degrees. And so just like the other examples, you have important information that you have to highlight. For reflections, you have to put the line where you're jumping over, and for vectors, you have to put the vector that you're changing. For rotations, you need a center and you need an angle. The center in this case was 0, 0, and the angle in this case was 90, rotating counterclockwise. And just like before, this is kind of arbitrary, but we need to identify the pre-image and the image. So I'm going to call this image 1, and I'm going to call this image 2. And so it goes from image 1 to image 2. And so there's no like formality in like tracking pre-image image. You just have to kind of tell me what's going on. Now, just like with the reflection rule, there is one here for rotations. But again, it's going to turn out to be a little bit different. In this case, we're taking x, y, and we're going to make it negative y, comma, x. And I can get that by just looking at the coordinates, and I can just ask myself, what patterns do I see? But just like with reflections, it's not that important that you understand or be able to identify it. It's important that you understand what you're basically going to see is two things. You're going to change the sign again, most of the time, change sign. But also what you're going to do, that's an ampersand, you're going to change sign and you're going to switch x's and y's. And so each of the coordinate rules has kind of a characteristic. For translations, you're going to be adding and subtracting. For reflections, you're going to keep everything the same place. We're going to change, make one positive or negative versus what it used to be. And for rotations, if you see x and y changing places, that tells you you're probably going to have a rotation. All right. And so if you turn the page to the back, I have everything kind of consolidated into statements, just like I had before. So you probably want to pause the video, try to answer these yourself, and then come back to the video and we'll answer them together to make sure you got it. So go ahead and pause the video, try it on your own. All right. So now that you pause it, try it on your own. Let's talk about these. Let's make sure we're on the same page as everybody, as each other. So if you know a shape has been translated, then you should see the object, and you can describe this different ways. But I'm going to put slide. Okay, you see the object slide on the graph using something and something vectors. And so this has got to be parallel, which means they have to be the same distance, and congruent, which means they move the same, I'm sorry, the parallel means they move the same direction, congruent means they're moving the same distance. Also, you should see an algebraic rule, and I would say that adds and subtracts to the x and y's, and a formal rule that identifies, and the most important thing is a vector, and that vector is going to look something like this, like those brackets A and then B, which translates to like xy going to x plus A, y plus B. And so if A and B were like 5 and 6, that would be x plus 5, y plus 6. If a shape has been reflected, then you should see the object that flips on the graph using a line of symmetry or line of reflection, but the important part being a line. Also, you should see an algebraic rule that usually changes the sign of either x and y, and a formal rule that identifies a line like y equals 4, x equals 3, x-axis, I spelled axis wrong, x-axis, or y-axis. And so the important thing is that you identify what that line of symmetry is. And so line of reflection, you have to identify within the rule. Finally, if a shape has been rotated, then you should see the object spin or circular motion on the graph using a circle, and that shouldn't say or, that actually should say and, an angle. You should also see an algebraic rule that changes the position and sign of the x's and y's, and a formal rule that identifies a center point and an angle of rotation. So just like 90 degrees around the point 0, comma 0, or you could say something like maybe 180 degrees around the origin. Okay, so that's all the notes. Sorry it took a little bit, but like I said, we want to consolidate. Sorry I couldn't be in class today, guys. I'm just not feeling very well. And so now your next task is 2 blue worksheets. Please work on those together. Work hard on them. I'm going to provide the keys, but please make sure you're gaining some information here because I don't want you to not do well in the quiz. And so about 15 minutes before the class,